Hi everyone, this is Module 6, Topic 2, Linear Programming Application 1. So in this topic, based on what we have learned in Topic 1, we want to solve a few more examples. So in this example, still we want to maximize the profit, but the constraints, the shape of constraints might be a little bit different from the example that we solved in the previous topic. The originally developed, this example is originally developed by Steve Wilson, and I just borrowed his example. Here it says we have a farmer, and a farmer has 10 acres to plant in wheat and rye. So he is producing two different products, wheat and rye. And many students may ignore some information, but when you solve linear programming problem, you must carefully look at each piece of information. For example, here, a farmer has 10 acres. That means the total available land is 10 acres. And given this land, he is planting wheat and rye. He has to plant at least 7 acres. This is another piece of information. The land uses must be greater than or equal to 7 acres. However, he has only $1,200. So from here, we have some constraints. So we have some budget, limited budget, and there are some costs for each planting. So to plant wheat, you have to pay $200 for each acre of wheat, and for each acre of rye, you have to pay $100. But the total cost must be less than $1,200. Moreover, we have some other constraints as well here. The farmer has to get the planting done in 12 hours. So there is some time limits as well. So 12 hours is a kind of available time. And it takes 1 hour to plant an acre of wheat and 2 hours to plant an acre of rye. So we have time constraints given here. Now, lastly, we have some profit function. So the profit is given. So let me use some different color. So the profit is $500 per acre of wheat and $300 per acre of rye. So the question is, how many acres of each should be planted to maximize the profit? So solving this problem, we will apply similar approaches. So we will formulate this one as a linear programming, and then we will graph the constraints to find the feasible reason. And lastly, we will compare the profit in each corner point to get the maximum profit. So let's try to formulate this problem first. So as the first step, we have to decide the decision variables. So the x decision variable in this case is number of, what is the dimension? Acre of, the first one is wheat. So wheat, the farmer will plant. Y is number of acreage of rye, the farmer will plant. So given x and y, or the farmer can control those numbers, x and y, how can we formulate objective function and constraints? First, profit function. It says that each acre of wheat brings $500, each acre of rye brings $300. Therefore, if we plant X acres of wheat, profit is 500X plus Y acres of rye, 300 multiplied by this number will give you the profit, and we want to maximize this profit. Now we have to consider several constraints.
Now let's consider constraints. We have three constraints. The first one is land or acreage. At the beginning, we read the description, and it says that the total land available is 10 acres. So land x plus y, the total land that you are using in acres must be less than or equal to 10. So here 10. And also we know that there is information given the total length must be greater than or equal to 7. So we have two constraints in terms of accuracy. And in terms of cost, it says that we need $200 for each X and for $100 for Y. So 200X plus 100Y must be less than or equal to total budget available 1,200. And what's the time uses? 1 hour for X, 2 hours for Y. So X plus 2Y must be less than or equal to 12. And of course, we have non-zero non-negative constraints here. So we have two equations for accuracy, one for cost, one for time, and non-negative constraints. If we summarize this as kind of a table, here we have equations for each constraint, and we want to draw these constraints as linear lines in the graph. So to do this, we will try to find the intercept for each line. So for example, the first one, x plus y is less than or equal to 10, we will make it as an equal sign. And then when x equals to 0, y equals to 10. When y equals to 0, x equals 10 as well. So we have x-intercept here as a 10, 0. Y-intercept 0, 10. Here we have second equation, x plus y equals to 7. Then similarly, when x equals to 0, y is obviously it's 7. And when y equals to 0, x is 7. So we have a 7, 0, 0, 7 as an intercept. Now let's look at cost function. This cost function is 200x plus 100 y equals to 1200. It can be easily rewritten like this. If I divided 100 by 100 in both sides, this is 2x plus 10y, 2x plus y equals to 12. So given this equation, when x equals to 0, you will get y equals to 12. When y equals to 0, x is, easily you can find it, it's 6. So what's the intercept? 6, 0, and 0, 12. The last one, x plus 2y, x plus 2y equals to 12. When x equals to 0, 2y equals to 12, y equals to 6. When y equals to 0, x equals to just simply 12. So we have 12, 0, and 0, 6 as an intercept. Now, with those given set of intercepts, we can draw the lines. So let's draw the line starting from x plus y is less than or equal to 10. We will draw those constraints step by step. This line is x plus y is less than or equal to 10. So x plus y equals to 10 line is given based on the intercept we found. Then we can plug in this origin, and if it's 0, 0, 0 is less than or equal to 10, so we have to include this side. So therefore, we can shade this area as a feasible reason based on the first constraint. Then what we can consider, we have another constraint, x plus y is greater than or equal to 7. So if this is x plus y equals to 7 line, now again, if you plug in 0, 0, 0 is greater than or equal to 7, this is a false. So therefore, you should not include this side, but you have to include the other side. So now what we have? We have a kind of common area, common reason based on x plus y is less than 10 and x plus y is greater than or equal to 7. And we have this feasible reason so far. Still, we have more constraints, right? So what is the other constraints? Here we have one more constraint, and this constraint is based on this line. So if you look at this line is, let me move back shortly. So we have this constraint, 200x plus 100y is less than or equal to 1200. So 6 and 12 is the intercept. So based on this, we have this line, 6 and 12. And since the constraint is less than or equal to, now we have to include this area. So far we have this feasible reason. And the last constraint, if you check the intercept is 12 for the x and 6 for the y. And it is again less than or equal to. And finally, we have this area as the feasible reason. So now we have this feasible reason, and we need to evaluate the profit. What we want to do, we want to maximize the profit. So you can draw the ISO profit line as we have done before, but as you can see in this tiny feasible reason, it is hard to decide whether at this point we have ISO profit, either maximum profit, or this or that. But at least we know that among those three corner points, we will have the maximum profit because in the middle we cannot get the maximum profit. So what we have to do is we can check the profit for all those three corner points. Okay, so here in the next page, let's say we have 3 points A, B, and C. For each point, this point is intersection of two lines. And if you check each of these lines, you can easily figure out A is the intersection of these two, B is the intersection of these two, C is the intersection of these two equations or these two lines. So now let me just briefly show you how to get the intersection. A, we have 200x plus 100y equals to 1200. First, I want to simplify it. So this is equivalent to 2x plus y equals to 12. Another equation we have to consider is x plus y equals to 7. Since we have a y term here, another y term here, we can just cancel out this y by subtraction. So let's subtract these two equations. Now y is cancelled out. We have x left on the left side and y on the right side. Now given x, you can plug in x equals to 5 either of this equation, and you will easily get y equals to 2. So A, we have 5 and 2. Now let's consider B. So for B, we have different two equations. The first one is the same, so let me just write down the simplified version of this equation. So 2x plus y equals to 12. I just divided each side by 100. And the other equation is x plus 2y equals to 12. So we are looking for B. Now, since the parameter for x and y are not same, what we are going to do, if this is equation 1, if this is equation 2, to make 2x, I want to multiply 2 in equation 2. Then now we have this equation converted into 2x plus 4y equals to 24. So now using this two equation, 1 and the 2, new 2 equation, so here let's subtract these two equations to cancel out x. Now on the left side, we have minus 3y. On the right side, we have minus 12. So y equals to 4. And given y, we can get x. Any equation you can use, but let me use this equation too. Then x plus 2, I plug in y equals to 4 equals to 12. So x plus 8 equals to 12. Then x will, you can get x equals to 4. So x equals 4 and y equals to 4. So B is 4 and 4, that is the index. Okay, now we have one more corner points. So let's try to find that one. So the last corner point is given by these two equations, x plus 2y equals to 12, and x plus y equals to 7. Since x term is the same with the same parameter, let's just subtract two equations. Then on the right side and on the left side, x will be cancelled out, only y left, and y equals to 5. Since x plus y equals to 7 here, we can easily get x equals to 2. So this C index is 2 and 5. Okay, so given three corner points, A is 5, 2, B is 4 and 4, and the C is 2 and 5, we can decide the profit. So what is the profit? Profit is, let me write down, 500x plus 300y. So therefore, for corner point A, profit is 500 multiplied by 5, 300 by 2, and you will get 3,100. And the 500 for 300, you can multiply by 4, then you will get 3,200. And the 500 x equals to 300 y equals to 5, and then you will get 2,500. So you will get the maximum profit 3,200 in corner point 4 and 4. So in your note, there are some details how to get each of these corner point. And here we can summarize this as profit A, $3,100 and $3,200, and the profit for C is $2,500, and the winner is B, and the profit is $3,200. So the maximum profit, $3,200, is obtained by planting how many acres? 4 acres of each crop. Thank you for watching topic 2.